Okay, so I'm introducing Chick Keller, who is among other things, he's a member of the Village Church Environmental Action Committee. Also, he is a KU Extension teacher. He teaches KU Extension classes, business and climate change, and maybe some others. So Chick, it's all yours.
Okay, on the title here, it says my name's Chick Keller, and I see on my screen share it's Charles Keller, or one and the same. Use any name, interrupt anytime you want, ask questions when you want. On the title, disaster is coming. I'm kind of a glass half empty type guy, and so I tend to emphasize the problems. Jerry has been coaching me to become a little more positive. So I said, well, we'll divide this class into two halves. The first half I'll do disaster is coming, and then next week I'll do there's hope for a better life. And I've kind of thought that through and how to position that. And now there's a little more on the titles coming up. Just a quick note on me. I do have 15 years experience working in the global energy industry. And that time I was working for Black Veatch, and it was about 1984 to the year 2000. And I traveled the world selling coal plants. But because of that, I do have a pretty good background in energy and can cover it pretty well. 2 years ago, and it's actually almost 3 now, I started teaching climate change kind of as a hobby while I'm in retirement. Plus, I thought I'd do some good at the same time. 2 years ago, when I started on climate change, I could barely get out a 90-minute class. In fact, I kind of struggled to do it the first time. But now I've literally read hundreds of articles, and I can talk for 10 hours pretty easy on climate change. And tonight we'll probably go about an hour and a half, depends on questions. I don't try to footnote everything, but one thing I do is I really don't have anything in this presentation that I haven't read at least 3 times from 3 different sources, which I think is real important to do because you get so many mixed informations today. You know, if there's anything that you don't think's right or you just want to know the answer, just Google the question. 2 or 3 classes ago, I had somebody ask me why it was hot in Minnesota last year. And I just Googled, why was it hot in Minnesota last year? And the answer comes up. I mean, it's just amazing what you can get on Google. One other thing, my English and pronunciation has never been good. And because I can't pronounce words, my spelling is questionable. And also because I'm dyslexic, I'll get things backwards. One of the last classes I was talking about the Southwest, US, but I was calling it the Southeast. Fortunately, a lady in the class caught me. For some reason, it's coming up and asking me a question here.
I think it just is showing a comment from Diane.
Okay.
I think that's what you're seeing. You just click it and it'll go away.
Okay.
Yeah.
Okay, alternative titles. And there's some messages in here and they're worth hearing. You could call it the possible 6th extinction. There's been 5 extinctions on Earth prior to this. If we keep on keeping on, in 100, 150, well, about 100 years, the population will probably be half, and 150 years, planet could be extinct. But I don't think that'll happen. This is a title I just read when I was reading the article. Most of these titles come from other articles I've read. Humanity is in denial, and it does seem that way at times. There's some research I'll share with you next week, though, that Jerry came up with, that 30% of America is concerned and 25% is cautious now. But we're beginning to get the momentum where you got to get up to that 70 and 80% of the population that's concerned and will do so. This is Bill Gates' title, How to Avoid a Climate Disaster. It's kind of a combination of positive and negative. It says, if we don't do something, we're going to have a climate disaster, and he's right. But then he lays out how to avoid it. His book is a good book, by the way. I recommend it if you're just looking for a nice, easy book to read. It's a good overview of climate change. Up at Fort Leavenworth, they're continually studying climate change and how it'll affect the armed forces of the United States. And one of their current titles is Code Red for Humanity. This next title is actually mine, Trillions of Dollars of Economic Opportunity and Destruction. And that's a true statement. And as climate change occurs, trillions of, in lots of industry will just go away, particularly like the gas industry and the oil industry. But there will be trillions of dollars of economic opportunity, and those that position themselves will do really well. Floods, droughts, storms, and fires, yeah, we've got them now, but the point you don't want to miss is it's going to get worse. As the CO2 levels continue to grow, and that's the plan, till we get the CO2 eliminated, the floods, droughts, storms, and fires will just get worse. Panic's an appropriate response, except you got to get yourself organized. Lastly, hope for a better life, and there is a better life. There's a lot of unhealthiness in the United States today, from heart disease to cancers to mental health. And if we solve climate change, it's going to improve all of those. So that's another reason to have hope for a better health. Whoops, wrong way. Okay, we're going to have two classes. I mentioned that. There is a problem, and there is hope for a better life. And that's next week, the hope for a better life. Tonight, what we're going to do, I'm going to spend about 10 minutes or so here real quick, just going through kind of a quick overview of the impacts of climate change and the cause of climate change. It's kind of a summary of the whole class, but I got some good graphics and I'm going to do it. Once we get, that'll take 15 minutes. Then I'm going to go through the simple science of climate change, of where the carbon dioxide comes from and why it's bad, why it doesn't go away, those type of things. Then the last thing we'll go through tonight, we'll talk about the economic impacts, billions of dollars of economic opportunity and economic destruction. Okay, average temperature per decade has gone up for the last 4 decades. The last 7 years are the hottest on record. Pretty strong evidence. So what? Well, nuts. Some of my slides disappeared from me. Sorry. I'm going to have to go grab a PowerPoint. Okay, can everybody see that?
Yes, I can.
Okay, the National Weather Bureau, kind of as a marketing activity and a good activity just to inform people about climate change, for the last 20 or 30 years has been tracking billion-dollar storms. And then they've been putting out good marketing material on it. This is one of them. And this is the map showing the billion-dollar storms in 2021. So that's last year. And there was roughly 21, I believe, last year. And the year before there was 22. But it's in that low 20 number in the last 2 years. Just for reference, if you go the last 4 years or the last 40 years, from 1980 to 2020, the average was $6 billion storms per year. If you look at the average from about I'm sorry, 2015, the last 5 years, 2015 to 2020, it's about 14 per year. So it is increasing. And you can see the types of storms you get. This particular year, 2021, fires out on the West Coast were a big deal. There's a lot of drought going on the West Coast. And even though there's a lot of drought on the West Coast, you get the occasional flood, that green bubble over there where you get a huge rain. That's another characteristic of climate change. You get bigger rains. We've got a lot of tornadoes. Some of us tend to think the tornadoes have moved towards, they don't come through Kansas being Tornado Alley anymore, but you can see there was 4 tornadoes with rain there in the Midwest. Coming up out of the Gulf, you get those red things. Those are cyclones and tropical storms. A lot more storms are coming up out of the Gulf. The reason is the Gulf is only a couple feet deep. It's getting warmer. It's like 85 degrees. So when storms pass over the Gulf, they pick up energy and turn into cyclones. Anyway, there's 20 or 21. I want to see if I can. Well, my screen keeps changing on me, so I'm going to have to stop share again in a minute. Okay.
Are you going back to your PowerPoint?
Yeah, here I got it.
Okay.
Okay, here's a screen that shows the billion-dollar storms in the year 2020. And you can see it's a different map, but it's kind of the same. In 2002, the fires weren't as big on the West Coast, but the cyclones and the tornadoes coming up out of the Gulf were a lot bigger. I remember once there was like 2 in a row in that particular year. Another thing that's bigger and shows up occasionally is the hailstorms. Like up there at the top, we've got hailstorms. During climate change, there's a lot more hailstorms, rainstorms, windstorms, etc. Huh. I just don't understand this, Jerry. It's kind of frustrating, but I'm getting better at it.
Are you in PowerPoint again or going there?
Yep, I'm going there. I'll be there in a minute.
Okay. I might mention while you're shifting that fires followed by rainstorms lead to mudslides, especially in California.
Okay, here's a precipitation map of the United States. In the brown areas, you're talking 15 inches of rain or less. The green areas on the right, you're talking 30 inches of rain type thing. The long-term impact of climate change, the rule is dry areas get drier, wet areas get wetter. So on the left-hand side, we're going to have more drought, and a good hunk of the left-hand side of the map where it's darker brown is simply going to turn to desert. A big hunk on the right-hand side, particularly the lower right, where it's darker green, you're going to have continual flooding, big storms and flooding. And, you know, if you watch the national news, which I do every day, and whichever newscaster you're out, Dylan or whoever, it's almost always rainstorms coming up in the Gulf area and going across the Alabama, North Carolina type region. on the left, it's almost always a drought or a fire coming up and getting worse. Interestingly, right in the middle where we are, we're not as impacted. We're kind of in a nice middle ground. One other thing you can pick up from this is when you talk about winners and losers, who solves water problems? Well, droughts and water sources are solved by civil engineers. Flooding, building new seawalls, building new levees, whatever, drainage systems of any type, raising roads, raising bridges is done by civil engineers too. So the demand for civil engineers in the next 20 or 30 years is going to be astronomical. Okay, one more slide and then we'll be done with this game, Jerry.
All right.
Okay, so what causes all this? And what causes it is CO2. And we're going to go into a lot more discussion on CO2. But the way CO2 is measured, and there's a graph of it here on the right-hand side of the screen, is parts per million. And back in 1960, that's the left-hand side of that. You can see the parts per million on that right-hand graph for like 315. And just as reference, back before the industrial age started, back like in the 1800s to 1850 time period, the CO2 parts per million were like 270. Now, if you look up at the upper right-hand side of this graph, and we're up to the current years, this is pretty accurate, we're up to almost 420 parts per million. We had fairly normal weather, in my opinion, up to the year about 2000. So, you know, and according to this graph, the parts per million of CO2 up in the air were 380. To stop climate change, we have to do two things. First of all, we got to stop this graph from going upward. And we'll talk about that in detail, how to stop the graph from going upward. But then we've got to remove CO2 from the air and get it from 420 down to like 380 or so, or lower. There are a lot of people say we need to get it back to 280. This is an extremely strong curve. And notice on there, even though we had COVID and about half, traffic went down considerably, the impact on this curve was negligible. So it's a big problem. That's a tough trend. The Paris Climate Accord sets a target to stop CO2 or cut CO2 growth in half, which just means change the slope of that curve so it goes up a little slower by 2030, and then to flatten the curve totally by 2050. But in that time frame, so I mean, the plan is for climate change to get worse and to really not get it under control till 2050. But in that time frame, the number of billion-dollar storms could easily go from 20 a year to 40 a year. It's not what you might want to call an extremely bright future. Okay, so we're back on the PowerPoint now. We kind of talked about this when I pulled up that slide, and those are the links on this slide to those graphics I just pulled up. But the Western US is going to see more fires and droughts and deserts. The Eastern US, more floods, hurricanes, and hailstorms. Now I'm going to move in an introduction to the cause of climate change. It's man-made CO2. Every element of modern day life requires electricity. And electricity, natural gas or gasoline. So electricity lights up your lights, natural gas heats your home, gasoline powers your car. Those are all fossil fuels. All fossil fuels cause CO2 generation. It's not a new normal, and it's going to get worse. The solution to climate change is going to require thousands. How that got there. Okay, let's go into causes and impacts of climate change. And what I want to say here, one of the articles I read, a researcher used artificial intelligence to work through the web and find all the articles on climate change and look to see if they were positive that climate change was occurring and man-made or not. At this point in time, they found 80,000 scientific papers on it, and 99% plus indicated climate change is real, that we have scientists studying it. Part of the reason there's so many papers done on it is there's like, I looked this up just today, there's 25,000 PhD programs in the world. And all the PhD programs around the world, they're trying to write thesis, and they're trying to write thesis on new knowledge, and climate change is all new knowledge. And virtually every discipline can do thesis on climate change. Sociologists can do those impacts, the psychologists, this mental aspect, the engineers, the engineering solution, the chemists, the physicists can all talk about what's causing it and what causes what and how we can solve it. Climate change is real. We've had big storms that we didn't used to have. At least I don't remember having storms like this when I grew up. I grew up in the 50s and 60s. We had Katrina in Louisiana in August in 05, Harvey in 17, Sandy in New Jersey, Maria in Puerto Rico, and Irma. If you look at these collectively, the impacts were 460 billion in damages, 1,000 people dead, 1 million homes ruined, 1 million vehicles ruined, and $1 trillion of lost economic activity, and forced migration. So on that, Houston, New Orleans, take where we had Katrina, the population in New Orleans is today 20% of what it lower than what it was. If you look at Puerto Rico, I think the population's down 50% from when that occurred. People just had to move. So we've got thousands of homes burning, and honestly, we don't have the manpower to rebuild all these homes. So 1,000 homes burned in Colorado, or I'm sorry, in California, 1,000 burned in Denver. The time frame to rebuild those homes is 3 to 5 years. The hurricane that happened down in Andover over the weekend, those will be 2 and 3 year rebuilds down there at least. So you kind of got some new themes developing. You recover, rebuild, and heal, or you migrate, start over, and heal. Neither of them are optimum choices, but that's what's happening. It's happening not just in the United States. I'm not going to read this list, but as I read headlines over the last couple of years, I just picked them up and threw them on this slide. I'll just cover the 2 most recent ones, which are the last 2 dot points. If you're following India and Pakistan right now, they're having an extremely hot period, and it's not even summer yet. Their electricity use is up a lot. They're having deaths from heat stroke and exhaustion. I think I covered that a little later. And they have dumps that are catching fire, which cause toxic air. In Chile, the country of Chile, they're experiencing decades of drought, same as Madagascar, where you're having people where food gets short. And, you know, with this thing that's happening in the Ukraine now, we're blowing out about 20% of the world's wheat crops. These food shortages, when I presented a year ago, I didn't think food shortages would be real. Now I'm beginning to believe there's going to be enough drought and enough problems that worldwide food shortage is going to be real and will drive up costs in the United States too on food. Okay, it has been known since 1850 that carbon monoxide holds more heat than normal air. So that's just a physical property. It's like some things you put in the microwave heat up and some things don't. Or if you ever use silver to serve coffee in, the silver heats up a lot, whereas other metals don't. So carbon monoxide heats up. In 1850 and before, we weren't burning fossil fuels. And as fossil fuels were being introduced, there was a scientist at that time that thought it through and predicted that climate change could occur. Today, we burn enough fossil fuel to emit 40 million tons of CO2 into the air each year. Now, when you read that number, you'll sometimes read 50 million tons. It's sometimes in metric tons and it's sometimes in English tons, and it will vary depending on how and when the measurement was taken. But all the numbers are consistent in the 40 to 50 million tons a year type number. Okay, the problem's a little bigger than just CO2 because there are other gases up there that hold heat too. In fact, there's three key, what we call greenhouse gases: CO2, methane, which is natural gas, which is what we use to heat our houses with, and nitric oxide. And probably one of the main sources of nitric oxide is nitrogen's in fertilizer. And when you lay fertilizer down, you're going to get a little nitric oxide. Methane has 70 times the impact of CO2. Nitrogen oxide is 20 times. When people are measuring CO2, they will often use the term CO2 equivalents, where they're taking the CO2 plus 70 times the methane plus 20 times the nitrous oxide and rolling it into one number. That's another way you'll get, if somebody says there's 50 billion tons of greenhouse gases, they're probably including both the methane and the nitric oxides. Okay, so these gases go up in the air, and this was a question I asked myself when I first started studying this. Why don't they just go away? You know, doesn't the wind blow them away out of Earth's orbit? The answer is that it doesn't. That the greenhouse gases are heavier than normal air. They're heavier than nitrogen and oxygen, which is what makes up normal air. So they hang around. CO2 can hang around 100 years, methane for 10 years. Later on, I'm going to talk a lot about how we've done a major switch from coal-fired power plants to gas-fired power plants. And gas uses a lot less, or creates a lot less CO2. And anyway, methane, the point I want to make, and I got a little sidetracked there, methane's only a 10-year problem. So the methane that gets up there will fix itself in 10 years. The CO2 that gets up there is a 100-year problem. And it's going to be a long time until it's fixed. Okay, some of this is review, and I've covered some of it, but we're measuring the greenhouse gases in parts per million. Prior to the Industrial Revolution, it was 270. Today, it's 416. We're growing 2 parts per million every year. So, and we want to limit it to 450. That's the goal of the Paris Peace Accord. And so if you divide that out, 450 minus 416 is 34. 2 parts per million growth every year. We'll get there in 17 years. So this is a problem we need to work on pretty immediately before it gets worse, before it gets out of control. One of the reasons the Paris Climate Accord sets that goal at 450 was they thought it was reasonable. It would be a stretch goal we could make. But two, there's things called tipping points where the problem just starts accelerating out of control once you hit 450. On some other slides tonight, I'll give examples of what tipping points are. Okay, CO2 is the problem. Where's it come from? The answer is burning fossil fuel. Coal produces 210 pounds per BTU that's produced. Gasoline, 157, natural gas, 117. And you can see that natural gas is half of coal. In the United States, we have switched our electrical production predominantly from coal to natural gas. So it's still getting CO2, but we've had a major reduction because of it. Then we've got our 4 zeros down here, which are wonderful sources. Hydro is kind of tricky because right now the biggest hydro plant in the United States is the Hoover Dam down there by Lake Mead, and that's going dry. So you've got to have hydro, you got to have water. And so a plant in the southwest of the US isn't going to make it. I guess there's a possibility we could make more plants in the southeast of the United States. Nuclear is at 0. In the United States, we're not going to build a nuclear plant because we're afraid of it. Interestingly, China, one of the biggest producers of CO2, and they're huge. I mean, their population of 1.5 billion, we're 350 million. So they're like 5-6 times bigger than us, and they're growing faster than us. So they need lots and lots of new electricity. They're installing more solar and wind than we're installing, but they're also, to keep up, they're building like 50 new nuclear plants right now. Also, Europe, France has always been kind of nuclear, and they've kept their nuclear. After the disaster in Japan, Europe was beginning to go off nuclear, but now with the problem with Ukraine, Europe is rethinking nuclear, and I think Germany's planning to build more plants too. And we can talk more about nuclear next week when I talk about solutions, but there are new types of nuclear that are safer and more modular and quicker to build. They're coming up. It's not all like today's nuclear. Okay, CO2 is the problem. Where's it come from? Well, we used to be the leader, and we used to put out the most billion metric tons. But today, China's by far and away the leader. China has lots of coal plants, and they're still building coal plants to make their economic miracle happen. Just in summary, their economic miracle kind of goes like this. You've got 100 million people out in the country that are in poverty. You move them into the city. You build a whole bunch of new apartments. You build a couple new factories. You build a couple new coal plants to fuel the factories. Then the factories and the people produce a lot of stuff. They sell all the stuff to us, the United States, and we're happy because we get all this cheap stuff. In the poor rural farmers in the China area that move into the big city, all of a sudden get up to almost a middle-class life. And that's the Chinese miracle. Anyway, because they're growing faster, in terms of who put the most CO2 up in the air, remember that CO2 hangs around for 100 years. We put the most up in the air. The China really only caught up and passed us in emissions in about the last 10 years. Okay, where's it come from? You can kind of break this up into 4, I guess there's 5 categories, but Transportation, that's mainly cars, but we've got airplanes is a problem too, and trains, etc. Electricity, we all use it, industry uses it. Commercial and residential, that's mainly to light and heat the buildings. Industry produce cement, steel, etc. is 22%, and agriculture is 10%. Now we're going to talk about the solutions to all these next week, but I just want to comment on them right now. We know the solution to cars. We know it's electric cars. We're moving pretty fast towards electric cars. We know the solution for electricity. It's solar and wind. And we're implementing that painfully slow. And there's problems in that right now because China makes a lot of the solar and wind panels, and they're making them with what's believed to be forced labor in central China from the Uyghurs. And so we've got some import restrictions going right now, and some of that that's slowing up new solar and wind coming into the United States. Commercial and residential, the heating, there really is not a great solution to the natural gas furnace that every home in America has. There is a thing called heat pumps. They mass installation. They're common, they're made today. They're just less efficient. And if you get one, it makes your heating bill higher. So most people don't buy them. For industry, there is no solution. Bill Gates is fine. Bill Gates says the only way to solve climate change is we've got to have a lot of new technology. If you say that's not true, he just says, what's your solution for cement? And there is no solution. And by the way, cement, there's, believe it or not, there's billions of tons of cement every year. Agriculture primarily becomes from cattle. It's a result of their digestive system. They burp a lot and it produces methane. Methane goes up in the air. Cattle are actually roughly 10% of the problem. The solution there is to get to plant-based food, which we'll talk about next week. Note, all these things I just talked about did not exist before 1850. And these are the core of modern day life. We don't do anything in modern day life that isn't in one of these categories. If we wanted to go back like living in 1850, your house would just be, wood walls with no air conditioning, no heater, no water, no nothing, no toilets. And none of us want to give that up. And that's also one of Bill Gates' themes. People are not going to give up, in his opinion, their lifestyle. So we have to come up with new technology that will allow people to maintain their current lifestyles, to replace these things above. Okay, let me stop there because I've been talking about CO2 and where it comes from and the impacts. And let's see if we have any questions out there, anybody, or comments that anybody wants to make on impacts and CO2, things we've been talking about. Anybody out there?
I have something I might just throw out. Maybe you're going to talk about this next week, but one of the natural solutions that people have been proposing is planting trees and engaging in regenerative agriculture.
Yeah.
Building the soil.
We'll get into regenerative agriculture next week, but it's real important. One of the sad things there is, it's not sad, it's a challenge. All our farmers today practice what's called industrial farming, which means you plow the field, you plant the field, you throw on fertilizer, you throw on a pesticide, you throw on a herbicide, you throw on a fungicide, and you get bountiful crops. The only trouble is you got to produce all those things and truck all those things. And all those things create lots of CO2 and problems. And we're going to go back to an old style of farming, where you, in regenerative farming, where you don't use pesticides, herbicides, fertilizers, etc. And you grass feed the beef.
Chuck, did you, in Bill Gates's book, I believe there's some information about agriculture in slash farming in Africa, and I do have some, some contacts in Presbyterian Hunger Program that feel that his solutions, are not socially just. They are mostly monoculture, as I understand. I haven't read the book, but this is what I'm hearing, versus allowing small farmers to have the opportunity to grow their own crops. Can you respond to that?
Not really. I can make a couple comments. I was with a lady my age that had just done a year's worth of missionary work in Ghana. And she said the people there are so poor, there's no way they're going to respond to climate change. They're just trying to exist. The other thing, I would say regenerative farming is going to help the poor farmer a whole lot, because he doesn't, one of the problems in farming right now is fertilizer is expensive and herbicides, all what they call their inputs are expensive. So, and we're going to go back to basic types of farming, and I think it will be good for the small farmer.
Yes, but my understanding, yeah, I think they are very poor, and certainly with all the potential drought they have. I know that China is building a huge dam in the area where I've visited a couple times, and that Heartland Presbytery sends through David Nishioka. I'm sorry, through David. Nishioka. Where he comes from in Kenya, there's a huge dam that's being placed on the river there, and so that's Chinese doing that work, which will help. But I think the concern was that Gates is promoting a monoculture, and then what will the people do? I mean, they'll have nothing to do.
Well, I think what you're saying, and I'm not going to blame Gates, I'm going to blame the Chinese. There is no doubt China has what's called their Belt and Road program, which just simply means they're going around the world investing billions of dollars to build major mining projects, major port projects, and they're doing it down in Africa. Yeah. China has the belief of when in Rome, do as the Romans do. And if the people down there don't care about mining, and if the people down there don't care about forced labor, it's okay with China. And they're just doing it, and they're funding it. So, and it is causing big problems in changing cultures. And it's a problem.
Mm-hmm. Yeah, lots of problems, no matter which way you run.
Yeah.
Thank you. Yeah, and I believe in regenerative agriculture. Absolutely, if we can get to that.
Yeah, we'll get there. I think what I've read is something like 20% of the U.S. is already there, and if that's true, that's phenomenal.
That's sweet. Sweet, yeah. Thank you.
Okay. Now I'm going to talk a little about weather and why things happen. And I just kind of want to go through some basic scientific principles and talk about those. Okay, air and wind moves from high pressure to low pressure. We all know that. If there's air in a balloon, it's high pressure, you let it out, it runs to low pressure. And So, and then heat creates high pressure. So high pressure is down by the equator where there's a lot of heat. Low pressure is up on the poles where it's cold and there's a lot of ice. We're going to have air moving from the equator towards the poles. The reason we're doing all this is because it gets into why the changes happen and why they're different. Now, right now, the poles are warming up a lot faster than any other part of the planet. So that means the temperature differential between the equator and the poles is different and it's changing. So it changes the wind patterns, changes climate. Okay, white reflects heat. So right now we got a bunch of ice up on the poles in terms of ice sheets and glaciers and things like that, and it's reflecting heat. As that ice melts and it turns to ocean, the ocean is dark and absorbs heat. So, and if that melting gets out of control and we lose a lot of that white, that's one of those tipping points where it just accelerates and getting worse. Okay, switching over to the farming topic a little bit. If you go on a baseball field or a child's playground or something, the earth is brown. You pick it up, it's powdery, just kind of falls apart. If you go to a good farm, it'll have black soil. It'll be like putty, contains millions of organisms. And the key to black soil or to cover on the ground is it absorbs moisture. Absorbing moisture is real important. Once you get to where all the dirt or ground is bare and brown, then you get a desert. So it's really important, like out in western Kansas and eastern Colorado, we need to keep ground cover out there. We need to keep the black soil. We don't want to let it go bare and turn into desert. Moisture absorbs heat and allows for plant growth. That's another important. If you've got moisture in the ground, it'll absorb some of the heat. If you don't, the heat just bounces off and heats up the planet. Ground cover prevents runoff. So here's another reason you want ground cover to control, to keep it ground from turning to desert, to bring in some heat, and then not to have runoff. You don't want to have the situation in California where the hillsides flooded. It knocks off all the, anyway, there's no ground cover on the hillside. You get the rain and boom, you've got a landslide. Or in Colorado where the fires ruin the hillsides, then you've got a runoff. Okay, unless anybody has any questions on those things, those are just ideas and kind of get into applications of it as I move forward. Okay, impacts on the ocean. The oceans act as a heat sink. They absorb CO2. The CO2 reacts with ocean water to form carbonic acid. So the oceans are becoming more acidic. As glaciers melt, and glaciers are above ground, so they add water to the ocean. And as the temperatures increase, water expands, so sea levels are rising. So the more acidic and warmer oceans change ocean life negatively. It negatively impacts coral formation. And I'm certainly not an expert in this area, but what I've read is that the coral formations are a key part of the food chain within the ocean. And as we destroy the coral formations, it's having huge negative impacts on ocean life. So oceans become warmer, more acidic, and less hospitable to life. And I don't know, something like a fourth of the planet or 40% of the planet lives off fish. So that's kind of a big deal. And a lot of people fishing's the main industry in their country. Any comments on that? Okay, let's move on to the polar ice caps. And just to note, everything I say, there are thousands of scientists around the world measuring stuff every day, and they're putting it into thesis and scientific papers, etc. So this talk about what's happening up there in the Arctic, there's a lot of guys measuring this stuff every day. The polar ice caps consist of a landmass, glaciers, which are masses of ice on the land. So there's actually glaciers in Colorado, except most of them have melted because it's ice on the land. Ice sheets, which are ice in the ocean connected to land, and then there's floating ice sheets. Note that all three of those have a good deal of their surface. Well, glaciers are entirely above water, and ice sheets and floating ice sheets are a lot above water too. The whole key to that is some people will tell you that when ice melts, it doesn't cause the ocean to rise because the ice is already in the ocean. But it's not. The ice is above the ocean. But when it melts, it increases the sea level. Two ice sheets, the Antarctica, 5.4 million square miles, and the Greenland ice sheet, 650,000 square miles. If the Greenland melts, which it won't, hopefully, it's because it's so thick. It's melting fast, and it's melting faster than we thought, but nobody expects for the whole thing to melt. But if it did, it would raise sea level 20 feet. You raise sea level 20 feet, and every coastal city in the world is wiped out. And something like 25, 30% of the population of the world lives in coastal cities. And by that, I mean Miami, Houston, Boston, etc. They're all going away. If the Antarctic ice sheet melts, the sea level rise will be 200 feet. Much more painful. And then here's kind of a comment on the tipping point. As ice sheets melt, the white ice, which is heat reflecting, turns to water, which is heat absorbing, thus accelerating the warming process. And it's kind of a belief that if we hit the 450 parts per million of CO2, it's going to be bad. The polar caps will start melting faster. Okay, this is just an article. Some studies have just come out in the last 6 months, and I've read several articles that all kind of refer to the same study. So when I've only got one study, it kind of bothers me, but it talks about the Thwaites Glacier in Antarctica. And what they've just discovered, it's melting from the bottom. Seawater has gotten warmer, and it's gotten warmer at the lower currents. You've got the Gulf Stream, which is moving the ocean around. It's moving the ocean down to Antarctica, and it's melting the glaciers from the bottom.
Wow.
The problem with this is that if some ice sheets break off, and which could happen, and that would, in melting, that might only cause 2 feet of rise, sea level rise. But if the structure breaks up, then the melting starts getting faster, and that could happen. And again, and this article is talking about this happening in the next 10 years. So this article is implying that places like Miami, New York, Tokyo, Shanghai are going to have severe water problems, may become unlivable in literally 10 to 20 years. I don't know that I believe that one, but I've read it. By the way, talking about another opportunity for civil engineers, pretty much every city in the world is talking about building a wall a big seawall between them and the ocean. And again, civil engineers designed those things. The city of Manhattan just finished a seawall that went around the entire island of Manhattan, and I think they spent a few $1 billion. I don't know how many. Louisiana's got a 50-year plan where they're planning on putting up $50 billion worth of seawalls over 50 years, preserve their state. Houston is out for bids, I think, right now to build giant seawalls, and they'll spend billions too. Okay, the big story, the polar ice caps are melting faster than we expected. So we may get more sea level rise, but as they melt, they're warming faster than the rest of the planet. That changes that temperature differential between the poles and the rest of the planet, which changes all the wind patterns and changes the weather. Okay, any questions? I don't know what's happening where you all are, but I'm out at Lake Lotawana, which is outside Lee Summit. And we're getting a great rain with a lot of lightning right
I'm
I
in
just like
Leewood.
to say,
I'm in Leewood, and I think the rain already moved by here.
now.
So
Oh, did it?
it's not all night.
Okay. Okay. Another characteristic of climate change.
We've got a question. Chip.
Yeah,
no, I just wanted to make a comment that the Dutch have already started building seawalls and have really advanced their technology on how to build some great ones.
who's that?
The Dutch.
The Dutch, yeah. The Dutch in the Netherlands and that general area over there, they are the world expert on, it used to be they were the world expert on reclaimed land, meaning their whole country was kind of built on marshes. And so they knew how to build walls and how to get the land back up. And like when the Hong Kong airport was built on a new island that was created, I think it was Dutch and Finnish engineers. Anyway, people have been doing that for centuries.
Yep.
They're experts.
I might mention that 10 years ago, I was visiting Venice, my wife and I, and we were on a downtown tour, and I asked our guide, I said, what are you going to do about climate change and rising sea levels? She said they were in the process of building a 3-meter seawall, anticipating a 2-meter rise.
Yep.
You think that would be sufficient?
Well, you know, that was a huge thing in the news about 2 years ago when Venice flooded. And
Yeah.
the seawall was, I think, 6 months from being finished.
Yeah.
And anyway, they flooded, and no, I don't think it'll be sufficient. I think all this building seawall things is just, you know, it's putting your finger in the dam, in the dike. But people are going to try. Everybody's going to try to save their city, and you can't blame them for trying. Okay, big storms become more frequent. Wetter areas get wetter, drier areas get drier, but when warmer air means more evaporation, thus there's more water up in the air. Warmer air means more energy's up in the air. And what makes storms is when you get a lot of water and you got a lot of energy up in the air, you get more storms and you get bigger storms. Down in the Gulf, because the Gulf's only a couple feet deep and off a lot of Florida, the water temperature is 85 degrees. I don't know, is anybody, I've been able to do this, and I'm curious anybody else, but if you go to the California coast and you walk out, the drop-offs are fast and it's cold. If you go to the North Carolina beaches or the Florida beaches, you can walk out 50 yards and the water's only waist high and it's warm. That warmer weather creates more storms. Weaker wind patterns also move slower. So you get storms stopping in place. So a couple years ago when we had 24 inches of rain in like 24 hours, and it was around the Houston area, Houston, Texas area, it's because the storm just stopped. There wasn't enough wind patterns to keep blowing it on. Okay, this last dot point's wrong. Oh no, that's right. It's Southeast is experiencing a lot more storms than in the past. They're going to have to, it ends up, you have to raise roads, raise bridges, etc. You might not think of raising bridges, but just think of the Country Club Plaza. How as Johnson County built up, there's more concrete out there, you get more rain, it all funnels into creeks that all come to Brush Creek. And then Brush Creek would flood to the point that, or the water would get up to the point that was hitting the existing bridges. So I think it was like 15 years ago, we had a major project to raise a couple of the bridges. That'll keep getting worse. Droughts and fires become more common. Warmer air sucks more water out of the ground. So that's creating the drought. Areas impacted are California and Colorado and generally the Southwest US. Because of droughts and because of winds, we're having record fire seasons. There's fires going on in New Mexico and Texas, I think, today. There's a huge projected water shortage in the Southwest US. You know, think Lake Mead. It's just gone down to nothing. In fact, you know, I hate to say it, but the people in that Arizona area, they truly are in denial. They all believe that water is going to come from someplace. And they're building, there's new cities and suburbs being built out in Arizona today that nobody's really sure where they're going to get their water. As the Colorado River keeps going down. Also, if that water, the water is getting low enough in the Hoover Dam now that there might have to be a cuts in electrical production, which is going to be a big problem. I forget the number of people, but it's like 400,000 people get their electricity from the Hoover Dam. Okay, rains greater than 2 inches or more common. And there's data on this. You can Google it if you want and get the number of rains greater than 2 inches, but there's just a lot more today and they have big impacts. So if you get that kind of rain on hills, like in Colorado, where there's been fires, or California where there's droughts and, you know, there's no ground cover on the hills, then you get mudslides real easy. In the big cities where you get wind, a lot of wind, like up in Chicago, and you break all the trees down, they clog the sewers, then you get a 2-inch rain and you get big floods. And then on fertilized farm fields, you get big rains and you get more fertilizer runoff. The fertilizer runoff problem is bad enough going down the Mississippi into the Gulf now, because once you get that fertilizer into the Gulf, in the warm weather, it grows algae blooms real easily, which hurts the tourist industry. And there's actually a dead zone in the Gulf that's 6,300 square miles. I couldn't believe that, so I Googled it twice to make sure that that was true. And it's a dead zone where nothing can live and tourists don't want to go either. extreme heat may force over 1 billion people worldwide to migrate. Let's talk about extreme heat. Basically over 120 degrees, but 95 to 105 degrees labor productivity drops. So I've actually worked in August in Kansas on construction projects in August, and you just can't do the work you do in June when the weather's more normal. At 105 to 120, heat strokes are likely. Over 120 is probably not livable. It depends a little bit on the humidity factor. But generally what's happened is the body's cooling system is just unable to function once your body gets up to 120 degrees. Extreme heats also leads to water and food shortages. Potential in areas of impact, I put down Southeast US and Northern Africa, but literally today, this is happening in India and Pakistan. And everybody there does not have air conditioning, and they're getting average temperatures for a week at 105 degrees. And it's a problem. People are dying. The average temperature in Phoenix a couple years ago was something like, trying to remember, I think it was 98 degrees, and that was the average of the days and nights. And they had several days in a row that were just over 100-degree temperatures, and some highs that hit as high as 120. Okay, anybody have any questions on those impacts? And those are kind of ruining society type impacts, and I'll move over and talk about the economic impacts in part 3 here.
Yeah, go ahead.
Chick, I was going to mention that it seems that when the impact stops being linear and starts being geometric, that's when things really are likely to fall apart.
Yeah, and you just defined a tipping point.
Yeah,
that's what,
and we haven't really hit one yet.
yeah, we're getting close though. Yeah, I agree.
So that will be when when a response will be required to continue to exist. And I guess some communities might make it and some might not.
Yeah, it kind of goes to the slide Jerry was showing me earlier, where like 30% of the US is kind of moving into panic mode now. When we get 60 or 70% of the US in panic mode because we get some of this geometric increase, we're going to get a lot of response.
I hope.
Yeah.
Yeah, I was going to ask, you mentioned that Arizona is not accepting the fact that this, the climate change is here. I think most persons in a lot of areas aren't. And I'm going to mention politics here. What about the leadership, the governmental leadership in those areas? Is that, I guess I shouldn't even bring this up because
well, leadership, I'm going to go through leadership next week. And just in summary, there's no leadership out of Congress because the Republicans have openly announced that they will not pass legislation related to climate change. The Republicans honestly believe that new technology will come and solve climate change. And I can say they may be right. And the Republicans believe that if the government gets involved, it'll make the situation worse. But then you move down to the state areas, and the governors of states are very, very territorial. So like the governor of Louisiana is leading a plan to stop climate change, preserve their coast, but at the same time to preserve the oil and gas industry down there. The water thing,
Yeah.
you know, everybody in Phoenix knows there's a water problem. They all know it. But it's the builders and the developers and the people that want to move there that are in the denial. They just keep building more houses, more suburbs. And the law isn't stopping them yet.
Okay, yeah, that, I can see that. Yeah.
Yeah.
Geez, thank you. Yeah, that's kind of, unfortunately, that's similar to a lot of bureaucracy and government. They just don't talk to each other. Yeah, so that's another thing not to get into, but thank you for that comment.
Yeah, the state governors are very oriented towards economic development. And down there, economic development is more tourists and more retirees moving.
Thank you.
Okay. $1 trillion of economic impact, some good, some bad. People are going to get rich out of climate change and people are going to go bankrupt out of climate change. So we'll start talking about that. And these are the various categories I'm going to talk about, from health impacts to recreational sports, forced immigration, insurance costs, shipping lanes through the Arctic, and potential climate catastrophe leads to a financial catastrophe. That's like if you own Puerto Rico bonds, they all went bad after that. They had the big storm, they couldn't repay them. Okay, insurance, these are a little out of order. Insurance costs will rise. Insurance costs by law are based on historical data. In other words, if you're projecting the number of storms in Florida next year, you've got to base it on the historical average. You can't base it on what will likely happen because of climate change. So they're a little behind the game. And they're also regulated by states. In other words, when the insurance company wants to get a raise in rates, they have to go get permission from the states, and the states have to approve it. And what they have to do is show historical data, likely losses, and then they can set their rates to cover the likely losses. It takes about 2 years for insurance rates to go up after major storms. So the 20 and the $21 billion storms that we had in the last 2 years, the 2 years ago, those rates are just going to start showing up next year, and the last year will show up in a couple of years. But rates are already going up. They're increasing like 20% in Florida. Rain and hail is happening fast along the Gulf Coast. It's not unusual now that homeowners insurance for normal middle-class Americans is hitting $5,000 to $10,000 per year. In some places, it may just get uninsurable. Okay, negative health impacts. And pretty much anything you do to fight climate change improves health. And let's go through this. Disease, more flooding in wet areas, like in Florida or Puerto Rico, allows mosquitoes and that type of animal to exist, and they create disease. Deaths, there's more deaths from heat strokes, floods, and fires. Mental health, people are kind of faced with problems they don't see them into. And you really have to group them together to get the whole picture, but it's income inequality, COVID, and climate change. And each one of them impacts different people. So over the weekend, I spent some time with a lady that had just moved from California, but she said in California, the minimum house is $1 million now. And young people out of college or young people that are 3 or 4 years in their career just have no hope to buy a house. I mean, the American dream is dead to them, so they're not working. There's others that just see COVID as endless and has ruined their careers. I'm talking mainly young people. And young people are much more aware of climate change than older people because they've been taught it in school. Schools have actually been teaching this stuff for the last 20 years. So they've got more fear. The mental health of the US is pretty bad right now. There's a shortage of mental health workers. But as we solve these things, it's going to help. Okay, lung disease. Fire produces smoke. So out in the California area, if you've got lung problems, your lung problems are worse now. And you can get toxic air too when the wrong stuff burns, like the dumps in India that are currently burning. So I guess what I'd say there is, since the government mainly pays for healthcare, the healthcare industry will probably flourish. We'll see more bigger hospitals all around. Recreational sports will be severely impacted. Southwest US, it's likely we'll stop watering golf courses. Oops, I got gold courses there, but we'll stop watering golf courses. Lake Mead used to be a big recreational industry. I read about a guy that owned 80 houseboats on Lake Mead and kept them rented out all summer. And when the lake got low, they called in all the 80 houseboats. So his income went from good to zero overnight. In Western Colorado, the ski season will likely shorten by 50% by 2005. The ski resorts are well aware of this. They're tracking it. They're trying to figure out what to do. I think the ski season's going down about 1 day per year on average, and has been going down, for the last 10 or 20 years. Used to be that you always had snow in Thanksgiving and the slopes opened on Thanksgiving. Now they're not. They can't get enough cold nights to produce artificial snow. You need nights below 32 degrees, and they can't get I think Denver this year went without a freeze till like December 17th of the year. So the cold nights were not there. Oh, there I've got a data point on it. 30 more frost-free nights per year in Colorado. So winter sports, outdoor sports all change. Coastal communities will be wiped out. 40% of the Earth's population lives on coastal communities. And the reason they get wiped out, they don't just get flooded. It's the storm and the storm surge. So if the sea rise is like a foot or two, but the storms, instead of producing 10-foot waves, produce 14-foot waves, then you've got a combination of 6 feet, and that just goes in and floods a lot more of like Florida. Florida's kind of flat. It'll, might move in a couple miles, flooding. Traditional biggest industry in coastal cities is fishing. That'll change dramatically. The coastal communities will spend billions building seawalls. Some coastal communities are sinking also. And what's happening there, they've been taking water, drilling for water, and their source of water has been wells. And then they've been pumping the wells dry. That creates voids underneath the city, and the cities are sinking. In the country of Bangladesh and Indonesia, their capitals are sinking so much that they're going to have to move their capitals cities to another place. The city of Houston is sinking very slowly. There it's a combination of, you got all those huge buildings up there and they're just heavy, combined with sucking the water out of the ground below. Then you've got another impact as you get those voids from sucking all the water out for well water, seawater comes in there. And in Florida, where that condo collapsed, there's one theory that seawater came in underneath the condo, and the salt water, the got into the basement, the concrete and the steel, and ate it. Coastal home prices, right now, Florida home prices are going up tremendously fast. And the reason is income inequality. The stock market doubled in the years 2019, 2020, and 2021. The market's literally doubled. So the upper 1 or 2% of the United States, people had 5 million, had 10 million, and the people that had 2 million had 4 million. People that had 50 million had 100 million, and home values went up. Everybody wants a second home in Florida, and I've got friends that don't afford that, but buy the $300,000 or $400,000 type condo in Florida. And, I asked them, what if it goes away? And they said, well, I can afford it. People that are buying those homes in Florida can afford a total loss. They're just not worried about it. Municipal bond defaults are likely. What happened in Puerto Rico, where the country couldn't pay off the money they had borrowed. Myself, I wouldn't buy a municipal bond from a coastal city today because there's just a chance they'll flood and they'll default. Okay, any comments or questions on any of that? We're getting to about my last slide here where I'm starting to summarize. Trillions of dollars of impact. And this is just illustrative. I've thought about it. And I just started writing down industries that will flourish and jobs that will flourish and industries that won't flourish or will be destroyed and workers that will have big problems. So in terms of economic creation and shortage, anybody that's a first responder to disasters is going to get wealthy. And Home Depot and Walmart are wonderful first responders. Home Depot has a weather department that will rival any weather department in the United States. They know where the storms are going to be. When they see the big billion-dollar storms coming, they've got their trucks going there. They'll be set up in the parking lots the day after the storm, selling blue tarps and generators and water and buckets and mops and everything. And Walmart does the same thing. So any type of store that's selling those disaster relief. Civil contractors, they're the ones that'll solve the water problems, be it too much water where you build dams or too little water where you got to move water around and build reservoirs. Home builders, there's a shortage of home builders right now, and it's only going to get worse as more homes get destroyed. So, and that brings up the job, skilled labor. Any skilled labor to build a home is in huge demand now and will stay in huge demand for the next 20 years. And by skilled labor, I mean the drywall guys, the trim carpenters, the rough-in carpenters, the roofers, all of them are going to have good jobs and good paying jobs. Water suppliers, anybody that can solve that problem in the Southwest United States is going to do well. Fire and wind resistant homes. I was reading an article about people that are rebuilding in California, and they're building fire resistant homes, a lot of concrete. Wind resistance, that's kind of adaptation down along the Gulf Coast. It's required to build homes on the coast. Not only you have to build them on stilts, but you have to build them to respond, to be able to withstand 100 or 150 mile per hour winds. Northern farmland, I thought this was pretty creative. As all the farmland moves north. For instance, I don't know if any of you read it, but about 4 months ago, there were some articles about cotton farming is coming to Kansas because it's getting drier and it works in Kansas now. But there was a private equity firm that could see farming all moving northward, and they went and bought a bunch of farmland in Canada, thinking that it would increase dramatically in value. And they're probably right. Industries are going to have trouble. Tourism, think Lake Mead, golf courses that are dry, lakes that are dry. Value of coastal property, they're all going up now, but they will go down as climate change gets worse. The fishing industry is going to have problems. Houses, businesses, cars, farms, and floodplains and storm zones. Municipal bonds of coastal cities. Service workers in impacted areas. That's not an obvious one, so let me cover that. But when you have these things, the professional workers can kind of work from home, or they can move and still work. The service areas, the people that work in the hotels and the restaurants, it's a lot harder for them to move, but they lose all their customers when the disaster happens. So they have a big problem. No, on the job site, I got tree trimmers. I just read an article today about the effort in the West Coast to trim all the trees around the power lines. And there aren't enough guys to do that. Firefighters, there is a shortage today on firefighters. And by that, I don't mean city firefighters, but guys that fight the wildfires. Any comments on that?
Okay, I have another comment. This is social justice stuff again. I
Okay,
noticed, yeah, Home Depot and Walmart have been well known for not supporting equitable, equality and social in various arenas. But
you mean like wages or
I'm
what?
Wages, Walmart, and so supportive of the quote little guy.
Okay. Well, Walmart's a big
And
helper.
persons that
Without
can't help
Walmart
themselves.
stuff, all Walmart,
But and here they're bullying out all the.
we lost you. Jerry, are you still there?
Yeah, I think she might be talking about maybe their supply chains. And also she's talking about, I think, how these big box stores tend to this render
Yeah.
it
Sorry, I don't know.
inoperative.
I think it's the wet.
Well, they bully the mom and pop stores, the
Oh,
smaller
yeah,
local
yeah.
companies.
You know, yeah, Walmart and Home Depot, as they come in, put a lot of small businesses out of business. In fact, all the big box stores do the same thing. They put the small businesses out. They pay low salaries. Salaries are going up, and hopefully they'll go up faster. But they're going to do well, and they'll be important. If you're a home flood and you have access to a Home Depot and Walmart, you'll be happy.
The good.
You're cutting out, Diane. I think it must be the storm. I'm watching it on TV here. It's kind of moving.
Yeah, I think so. Okay, but thank you.
But I agree with you. They're not the greatest corporate citizens.
Yeah, so they're after the money, maybe, rather than really helping people. That's what I'm thinking.
Oh, I think that's
But,
for sure true. Yeah, disaster.
Yeah.
They don't have to put things on sale to the disaster site.
Yeah.
Sell at full price.
Yeah.
Their business model is to be ambulance chasers.
Yeah, there you
Oh,
go.
dear. Well,
That's exactly right. Okay, well, I think I'm getting to the end here. Okay, a word of caution, switching to topics. Weather is weather and climate is climate, and they're different. So weather is what we get. This is Mark Twain's greatest quote. And climate is what you expect. So what I've been talking about all along is climate. And what we can expect in climate, more storms, more drought, more fires, etc., over the next 5 or 10 years. But weather is an extremely complex thing that has lots of variables to it. I've tried to get to understand how you forecast weather, and you just can't forecast weather. It's hard. Anyway, so
Except
we-
over really big events.
yeah,
Then climate and weather come together. But like
yeah,
you
over
say,
time,
it's the discrete pieces that people feel in a particular locale that's
Yeah.
tough to tie down.
but we could, over the next year, maybe have $2 billion storms. And then the year after that, you could have 25. I mean, there's a lot of variability in this stuff. Weather just kind of happens. And there are still record low temperatures occurring, but there's more record highs occurring. And then this was literally an article in the paper. They asked climate scientists, was the massive tornado that was in the Kentucky area, I think it was about 6 months ago, was that caused by climate change? And the scientists would not answer the question. They just said, well, it could have been.
I think the stock answer is to say that most problems, for most problems, climate change is a threat multiplier.
Oh, that's true. That's
If
a
the
good
threat's
statement.
there and it's going to happen, climate change makes it worse.
Yeah, I think that's probably true. Okay, there is a summary. All aspects, or class 1, there is a problem, and here's the summary. All aspects of modern day life use energy, which generates greenhouse gases or CO2. There are more fires, storms, droughts, hurricanes. It's going to get worse. There's going to be more billion-dollar storms. Decent estimate, 1 billion people will be forced to migrate or lose their job or have a severe impact on their life. And that's out of about 7 billion people on the planet. So 1 out of every 7 probably going to be impacted. Trillions of dollars of property will be destroyed. Trillions of dollars of economic opportunity will be created. There's both halves. And as I announced earlier today, I was going to present the problem in the glass half full. I'll try to flip over next week and present the glass as half. I'm sorry, I did half empty today. Do the glasses half full next week. And why there's hope for a better future.
Earlier, I think you quoted Mark Twain. There's another saying attributed to him, I think, that says, if we keep doing what we're good, if we keep on doing what we're doing, we're going to end up where we're going.
That sounds like Yogi Berra.
Well, yeah, okay.
But yeah, it's a good quote.
Nobody goes there anymore. It's too crowded.
Yep, that's right.
Thanks, Chick.
Okay, yeah, I'm done.
I'm going to go ahead and stop the recording. And if anybody wants to say anything that they don't want to be recorded, now's the time to do it.